In this video, you are going to learn how to balance a redox reaction. That is, to balance a redox reaction in either in an acidic solution or in a basic solution. Here is an example. If you have an equation like this, if you look around, you can see oxygen that is on the left side and you don't see oxygen on the right side. So how can we balance it? So in this case, it must be in a solution, aqueous solution, either in an acid solution or in a base solution. Okay, so let's see. Let's try to balance this equation. The first step is to write this equation into two halves reaction equations. The first one will be, let me put it this way, I have Fe 2 plus, that is going to give me on the other side Fe 3 plus. And by the way, the oxidation number increased, that means it is oxidized. Okay, so what is the other half reaction? It is Cr, chromium, O, this oxygen, and 2 minus. I just copy it from the original equation here, and that is going to give me Cr3 plus. And by the way, what is the oxidation number for the chromium on the left side? The whole thing is going to carry a 2 minus charge. Oxygen is 2 minus for each. So now we have negative 14, and therefore two of these together will be positive 12. So each of the chromium will be positive 6. Okay, so how do we balance it? So the first step is to write the two half reactions. Okay, so write the two half reactions. We just did this part. Okay, so what is the next step? The next step is to balance all elements except oxygen and hydrogen. Okay, let me write that down. The second step is to balance all elements except oxygen and hydrogen. Okay, what do I mean by that? Let's see. Fe, that on the left side I have 1 and on the right side I have 1. Okay, so it is balanced. How about the second half reaction? On the left side I have 2 and on the right side I have 1. So it's not balanced. How can I balance it? Yes, I have to put a 2 over here to balance it. Okay, so now the elements other than oxygen and hydrogen, that means only chromium in this case, is balanced. Okay, number 3, step 3. Step 3 is to balance the oxygen atoms by adding water molecules. Okay, so let me write it down. Is to balance oxygen atoms by adding water molecules. Okay, so what should I do here? The first half reaction, oxygen is balanced. The second half reaction, I can see oxygen on the left side, but I don't see oxygen on the right side. So how many oxygen on the left side? I have 7. So in order to balance it, I have to add 7 water molecules, because in each water molecule I have 1 oxygen. So now oxygen is balanced. Okay, so what is the next step? Let me change the color. Okay, So the fourth step will be balance the hydrogen by adding hydrogen ions. Okay, so balance hydrogen atoms by adding H plus ions. Okay, so how do I do that? Let's see. Over here, hydrogen, I have nothing on the left. Well, on the first half reaction, we don't see hydrogen, so that's fine. Over here, we do not see hydrogen on the left, but we see 14 hydrogen on the right, and therefore we have to put 14 hydrogen plus to it. Okay, so now hydrogen is balanced. Okay, so what is the next step? Let's get back to the other color. I like to pick the red color. Okay, now the fifth step is to balance the charge by adding electrons. Is to balance the charge by adding electrons. Okay, so over here, the first half reaction, I have 2 positive charge on the left side and I have 3 positive on the right side. So which side should I add electron? Because electron is negative, and if I put a negative electron on this side, okay, so now on the right side, 3 positive plus 1 negative, it will be 2 positive. All right, so let's look at the other one. Over here, what is the charge? On the left side, I have 14 H plus, so I have 14 positive, I have 2 negative, so the net charge now on the left side is 12 positive. Okay, so how about here? I have 3 positive, but I have 2 of them, so I have 6 positive. So what I need to do is, on the left side, I need to put 6 electrons. So plus 6 electrons on the left side in order to balance the charge. Let me repeat what I just did. I count for the charge on both the left side and the right side. On the left side, I have 16 positive plus 2 negative. So before adding the electron, I have 12 positive. On the right side, I have 2 times 6, I have 6 positive. So how can I balance it? I'm only allowed to add a negative charge. If I put more negative here, that means it's less. Okay, so I have to put the negative on the left side in order to get rid of the extra positive. So 12 positive plus 6 negative. So on the left side now I have 6 positive, and now on the right side I have 6 positive. So it's balanced. Okay, so what is the next step? Now the last step, it is to multiply the half reactions so that the number of electrons on both sides will be the same. See, if you just add them up, you see 6 electrons over here, but you only see 1 electron over here. In this case, what are we going to do? I am going to multiply the first half reaction by 6. If I multiply that by 6, then I will have 6 Fe2 plus is going to give me Fe3 plus, I have the 6 over here, plus 6 electrons. Now I can add these 2 up. I know it's a little bit messy here. Okay, so when I add it up, I can cancel out the electrons on both sides. And what do I get at the end? Wow, I need to write it really clearly now. I will have 6 Fe2 plus, and plus I have Cr2O7, 2 minus. Also I have 14H plus. I have well, the electron is gone. Okay, so I don't want to write the electron. Let me erase this one. Okay, because it canceled out on both sides. Okay, so on the right side, what do I have? I have over here, I have 6 Fe3 plus. Electron is gone, so it plus 2 Cr3 plus 7 H2O. I just copy whatever done is here. All right, it looks complicated, but it is balanced. What do I mean by balanced? The elements, the number of atoms on each side is balanced. Okay, the charge on each side is also balanced. That is important. Okay, it seems complicated, so let's try another example. Okay, so let's do an exercise. Now, if I give you the following, how about Al, aluminum, plus Ni, that's nickel, Ni, 2 plus is going to give me Al, 3 plus and Ni. Okay, so let's look at it. Aluminum on the left side is in its elemental form, so the oxidation number is 0. Over here is 3. So aluminum is oxidized because the oxidation number increased. Nickel, look at this, is 2 positive to become elemental form, that is 0. So nickel decrease is reduced, undergo reduction. Okay, so let's go over all the previous steps. The first step is to write it into 2 half reactions. Okay, so I have aluminum will become aluminum 3 positive, and nickel, Ni, 2 positive will become Ni, just Ni. Okay, so the first step is to write down the half reactions. Okay, so what is the next step? The next step is to balance all the elements except hydrogen and oxygen. Okay, so over here, aluminum on the left side 1, on the right side 1, aluminum is balanced, and over here, nickel is also balanced. So I'm done with that step. So the first step is to do the half reactions. So write down 2 half reactions. I finished that. The second step is balance all elements except oxygen and hydrogen. Okay, and that is done. Number 3 is to balance the oxygen by adding water. Okay, is to balance oxygen, okay, by adding water, but we don't have oxygen here, so that's fine. Number 4 is to balance the hydrogen by adding H plus. Okay, we don't have hydrogen here, so that is fine. The next step is to balance the charge by adding electrons. Okay, so I'm going to change the color here. Okay, so step number 5 is to balance the charge. Balance the charge by adding electrons. Okay, so over here, is the charge balanced? No. On the left side, there's no charge. On the right side, I have 3 positive. So what I can do is I add 3 electrons to it to make it neutral. Okay, over here, I add 2 electrons to the left side. Now it is balanced. Okay, so what is next? I have to make sure that the electrons are balanced. So what I can do is I multiply that first half reaction by 2. And then I multiply the second one by 3. Okay, so the electron can cancel out. So what I will have will be 2Al plus 3Ni2 plus is going to yield 2Al3 plus and plus 3Ni. Okay, so now each element is balanced and the charge is also balanced.